Hello everyone, today we're going to talk about graphing more quadratics and finding some more characteristics about them. First we're going to review some interval notation. So for number 1 we want x is greater than 3. So that means that 3 will be our lower bound and infinity will be our upper bound. And we're going to say parentheses on 3 so that we don't include it since it's just greater than. For number 2 we want all the numbers that are less than 4. So 4 is our upper bound and negative infinity will be our lower bound. We want a bracket on 4 because we're going to include 4 since it is less than or equal to. Number 3 is a compound and, so our lower bound is going to be 2. And our upper bound is going to be 5. For 2, it's a less than sign, so we're going to have it open, so we're not going to include 2. And 5, we're going to include 5 since it's less than or equal to, so we use a bracket. For a compound or, we're going to create two separate intervals. So we're going to say all the numbers less than 2. So 2 is our upper bound and negative infinity is our lower bound. And we're going to use a parenthesis since it is just less than. And then 3 is our lower bound and infinity is our upper bound for all the numbers greater than 3. And we use a parenthesis for that. For using both forms, we want to be able to convert between both. Sometimes one is more beneficial than the other. So when we are converting from vertex form to standard form, we want to distribute or FOIL. So we want to rewrite this as x plus 2 and x plus 2 so we don't make any common mistakes. And when we FOIL that out or distribute, we're going to get x squared plus 4x plus 4. And then combining like terms will result in x squared plus 4x minus 1, making sure we're writing in proper standard form of descending order. Looking at converting in the opposite direction, so there are actually two ways you can do this. We're going to use your previous knowledge on finding the axis of symmetry or the x value of the vertex using negative b over 2a. What we need to do is find our h value, which is that, and our k value, and then we're going to use the a value that's already in the problem. So using negative b over 2a, we're going to say that this is negative 20 over 2 times 2. Two negatives make a positive, and we're going to get over 4, which leaves us with 5. When we plug 5 back in, we're going to say 2 times 5 squared minus 20 times 5 plus 54. This is going to result in 50 minus 100 plus 54, which will result in just 4. So our HK is going to be 5, 4. And then we have our a value from the problem, so our final vertex form will be y equals 2 from the original problem. That's the only thing that transfers over. X minus 5 squared plus 4. Looking at some of the characteristics, you're going to find that we're going to find all these, so it's important to know the vocabulary. So you can pause the video and copy these down so that you have them when we go over them later. Looking at graphing the quadratic and then finding the information, we found these two pieces previously. So we're going to use the same kind of ideas on how to find those in graph, and then we're going to find the rest of the answers. So for this one, our vertex, we're going to use the opposite of 1, which is negative 1, and our k value is 3. The key important thing is we need to pay attention that when we graph this, we're going to have a reflection and a stretch at the same time. Our axis of symmetry we can find from the same information saying it's x equals negative 1. So I'm going to graph the axis of symmetry, and then our vertex is at negative 1, 3. And then using that negative 3, we're going to go right 1, down 3. And if we want to go another point, we're going to go right 2. We normally go 4. We're going to go 4 times negative 3, which is down 12 to down here. We can reflect these across the axis of symmetry to give us a parabola that looks something like that. For a domain, we should know that our domain for quadratics are going to be all real numbers because we go all the way to the left and all the way to the right. Our range, our lower bound is negative infinity in this case because we open down, and our upper bound is going to be 3. We're going to include 3 because we have that point negative 1, 3 in the actual quadratic. For increase and decrease, if we start on this side, we are noticing that we are increasing until we get to the x value of negative 1. Remember that these are x values. So we are increasing from negative infinity until negative 1. At negative 1, we are not increasing or decreasing, so we're going to use a parentheses. After that value of -1, we start decreasing. So we're going to decrease from -1 until positive infinity. For your zeros, we want to find what values do we cross the x-axis. We cross at -2 and 0. If you didn't have it on your graph, you can always solve by plugging 0 in for y. Our y-intercept we also found was 0, 0. And for intervals of positive and negative, we want to make sure that we are using the zeros. So these zeros, so we start on this bottom area, we start when x is -infinity, we are going to be negative until we get to the first x-intercept of -2, or the 0 of -2. So we are going to say that we are negative from -infinity until -2. And then after -2, we become positive. And we're going to be positive until 0. And then we're going to start being negative after 0 until positive infinity. Now we want to use parentheses on these because at -2, our y value is 0. So that's neither positive or negative. And the same thing at 0, 0. The y value is not positive and it's not negative, so we do not include those. I skipped the y-intercept, which we found to be 0, 0. I might have just erased that. So remember that your increase, decrease, and your positive, negative are all x values, but increase, decrease uses the vertex. Positive, negative uses the zeros. All right, if we don't have a graph, we still need to find these and just do a quick sketch. So we're still going to find the vertex. We're going to use standard form, so we're going to say -b/2a. And that's going to end up being -1. If we plug that back in, so f of -1, you could use a calculator to speed this up. But we're going to get 1 minus 2 minus 8, which is -9. So our vertex is -1, -9. Our axis symmetry is x equals -1. If we do a quick sketch of this, we're at -1, -9, which is down here, and we're going to open up, so it's going to look something like that. And we just need that general idea to know when the function turns, when it's above the axis and whatnot. So looking at the domain, we should, like I said before, it's -infinity to infinity. Our range, since we are opening up in this case, is our lower bound is going to be the y value of the vertex to positive infinity, and we're going to include the -9. We're going to start on the left arrow, and we are decreasing as we go to the right, so we start decreasing from -infinity until the vertex, which we use the x value, and the vertex x value until positive infinity will be increasing because it turns and starts increasing from there. For zeros, we don't know since we haven't graphed all of our points yet, but for any time we are trying to find zeros, you're going to plug in 0 for y, hence the name zeros, and we're going to solve for there. You can solve a bunch of different ways. You can factor this to be x plus 4, x minus 2, so we're going to get x equals -4 and positive 2. I would strongly suggest writing these as in numerical order because that's going to help you out later on. So we have -4 and positive 2. Our y-intercept, we should be able to just plug in 0, which in standard form we can always just use our constant term. So we're going to have 0, -8. And then positive and negative, we should recognize now that this is -4. And this is going to be 2. And so we start on the left arrow for when x is -infinity, we're going to be positive until that first 0 of -4. And then from -4 until 2, we are below the x-axis, so we are negative. And then at -4, we start being positive again. So you just have to recognize when and where you cross the x-axis and which value comes first.